Welcome back, everyone. So we were working on lesson 12, where we were looking at the secant angle theorem exterior case. Now remind yourself about the secant angle theorem, both the interior and the exterior cases. Then we had moved and filled in this graphic organizer with the inscribed angle theorem and the family of theorems that goes with it. We had looked at the inscribed angle theorem, the secant tangent theorem, then the secant angle theorem, both the interior and the exterior case. And then we had extended the secant angle theorem exterior case to tangents also, and we saw that the same theorem applies whether I'm looking at tangents that meet outside the circle or two secants that are intersecting outside the circle. Now, till now we have seen in this lesson when secants are intersecting whether inside the circle or outside the circle, what are the angle measures that are getting formed as a result of these intersections? Moving on, we are going to look at how can we find the length of these secants and how do they get divided up. So let's look at the first theorem here now. You can see that I am looking at intersecting secants that intersect in the interior of a circle. So here I have two secants that are intersecting inside the circle, and they are getting divided into these ratios. So this length, let me call them A, B, C, and D, and the intersection point is E. So I'm saying AE is A and EB is B, and so are ED and EC are C and D respectively. So I am trying to see when these two secants intersect each other, they cut each other into some ratios, and is there a connection between how these get cut? The relationship that I will see is that A times B, so A times B will equal C times D. A times B will equal C times D. In the next theorem, I am looking at two secants that are this time intersecting outside the circle. So these are now intersecting outside the circle. So let's start by writing that down. At this time, I am looking at two secants intersecting in the exterior of a circle. And as you can see, they are intersecting in the exterior of a circle. Now again, this this length is A, and this length is B. Excuse me. So this secant, some part of it is outside the circle and some part is inside the circle, and same with this other secant. So C is this length and D is this length. So the relationship between A, B, C, and D is A times the entire length of the secant, A plus B, will equal C times C plus D. a times a plus b equals c times c plus d. Now please be very careful here. So in the first one, I was saying how they were getting cut as a times b was equaling c times d. But in this case, it's a times the entire length is equal c times the entire length. And the last one is, I am now looking at, let me make this clearer. I am looking at a tangent and a secant. Secant intersecting in the exterior of a circle. So here, length A, it's clear that this length BC is the length A, and this length is B. B is the length of the secant from the intersection point to the circle, and C is the length of the secant that is inside the circle. In this case, I will say, so in this case, from B to C, it is A. So it is basically A times A is equal to B times B plus C, or A square equals B times B plus C. So on this page, I'm looking at 3 new theorems, and they are basically telling me how is the length of the tangent or the secant getting divided, and is there a relationship between how these get cut. To look at the proof for these 3 theorems, I want you to go to the resource that I have posted on Google Classroom. On the same, I will post it on this same document. So please go there and look at the proof of these 3 theorems. So pause this video here and then go to the resources there. So resource 1 will give you the proof for the first theorem here, and resource 2 will give you the proof for these 2. So go ahead and look at those resources right now for me. So you can pause the video here. Okay. Now that you've understood these 3 theorems in more detail, let's start looking at the how we are going to use these theorems to figure out the missing side length. So here I'm looking at 2 secants that are intersecting inside the circle. So I know that 4 times 12 should equal 6 times x. So this is the first theorem that we looked at today. So x will be 4 times 12 divided by 6. So this is going to give me x equals 8. Problem 2, I am now looking at a tangent. I'm again looking at 2 secants, but this time they are intersecting outside the circle. And when they intersect outside the circle, I have to be careful that the length of the secant that is outside from the point of intersection, which in this case is x, plus the entire length of the secant, which is x plus 1, should equal, again, this length from the intersection point to the circle, which is 2, times the entire length of the secant, which is 2 plus 4. The mistake people make here is they will do x times 1 equals 2 times 4, and that is incorrect. So please be careful. Okay, When I open the parentheses, guess what? I am ending up with a quadratic equation. X squared plus x equals 12. So to solve that, I am going to use factoring. I don't know how many of you remember how to solve a quadratic equation using factoring. So a quick review of that. So if I have my equation x squared plus x minus 12 equals 0. Remember how I was solving it? I was putting a times c here and b here. And you remember in standard form, my quadratic equation looks like ax squared plus bx plus c equals 0. So in this case, a is 1 and c is negative 12. So 1 times negative 12, which is negative 12, and b in this case is 1. So I'm looking for factors of negative 12 that add up to 1. So factors of negative 12 that add up to 1. So I have my first factors are negative 12 and 1, and also 12 and negative 1. That doesn't work. Let's go to negative 2 and 3. Negative 2 and 6, or 2 and negative 6. That doesn't work either. Let's go to negative 3 and 4, and 3 and negative 4. This is what will work, because negative 3 plus 4 will indeed give me 1. So I have negative 3 and 4. So my factored form will be x minus 3 times x plus 4 is 0. So either x minus 3 is 0 or x plus 4 is 0. So either x is 3 or x is negative 4. I know in my case x is the length of a segment, so it cannot be negative. So my answer will be x equals 3. If you guys have forgotten how to solve a quadratic equation using factoring or using your quadratic formula, this is a good time to review it. Okay, so I got x equals 3 here. If you want to look at the solution again, here it is. So I'm looking for factors of a times c that add up to b. Let's look at number 3 together. In number 3, I'm given this length is 7 and this is 6, but I'm also given these restrictions. The df is less than fb, it is not 1, and it is also less than fe.